Take two. All right, we're gonna try this problem again. I did it and didn't get the answer in the back of the book, so I'm gonna have to do it again. I thought I had it. Oh, you guys know how that works, I'm sure. Okay, so let's try this again. So we've got this differential equation with this impulse condition, but now this impulse condition only works in this window. Okay, so let's go ahead and take the Laplace transforms first. L of y, as usual, is going to be script y. L of y double prime is going to be s squared y minus s y of 0 minus y prime of 0. Okay, that's normal. Just get this out again. Okay, so y of 0 is 1, y prime of 0 is 3. So this is going to be s squared script y minus s minus 3. Okay, so far so good. Okay, now let's look at this g of t. I'm going to write this g of t sort of a special way, all right? Because it's only acting in the window from 0 to 2 pi. Notice I said window. That means we're going to use the window function. Okay, so g of t is sine of t times the window from 0 to 2 pi. Okay, but now remember the window is the step function of the bottom minus the step function of the upper boundary. Okay, so this is sine of t times u of t, okay, because it starts at 0, minus sine of t u of t minus 2 pi. So it ends at 2 pi. Okay, so we're going to use this Laplace transform. Let me go in here. We're going to use this one. The Laplace transform of g of t times a step shifts you to the other side. Okay, so let me write that down here. Oh. We're going to let me write it down somewhere. I have it. Or I don't. I have it. So the Laplace transform of u of t minus a times g of t equals e to the negative as times the Laplace transform of g of t plus a. Okay, that's number 11 in the table. Okay. All right, so let's go ahead and take the Laplace transform of g through this. Just a note, this is a different g. This is a g from the Laplace transform table. So just to keep that in mind. Putting this through the Laplace transform, okay, so we're going to get the Laplace transform of our g of t here is going to be, now, the u of t doesn't really shift anything. So the Laplace transform of sine of t times u of t is just going to be the Laplace transform of sine of t. Minus. This is going to shift everything to the right by 2 pi. So this is going to be e to the negative 2 pi s Laplace transform of sine of t plus 2 pi. But now, sine is 2 pi periodic, right? So I can actually just get rid of the 2 pi. Okay, so that's because sine of t plus 2 pi equals 2 sine of t. Okay, so now what is the Laplace transform of sine? Let's go over to our table. That's just going to be, in this case, 1 over s squared plus 1. So that's going to be 1 over s squared plus 1 minus e to the negative 2 pi s 1 over s squared plus 1. Okay? All right, so we've got our Laplace transforms. Okay, now let's go ahead. We're going to run our differential equation through the Laplace transform machine. Okay, so that means we're going to have y double prime. I've written it down, s squared y minus s minus 3. Sorry, it's so small. I'm just trying to be able to see everything that I'm doing. Plus 4 times y, okay, has to equal 1 over s squared plus 1 minus e to the negative 2 pi s 1 over s squared plus 1. Okay, so far so good, right? Okay, let's go ahead. We're going to have to solve for y, of course. So I'm going to write this as y s squared plus 4 equals 1 over s squared plus 1 minus e to the negative 2 pi s. Let me move this down a little bit, running into the other stuff. 1 over s squared plus 1 plus s plus 3. Okay, now I'm not going to combine these. I thought about doing this. Maybe I could combine this with this. But in this case, this and this are the same. So I'm not going to make my life easier doing that. Okay, so y, of course, y of s, I should be writing that, but I don't, equals 1 over s squared plus 1, s squared plus 4, minus e to the negative 2 pi s, 1 over s squared plus 1, s squared plus 4, plus s over s squared plus 4 plus 3 over s squared plus 4. Okay, I already caught my mistake from last time, thank gosh. Okay, so now, not going to gain anything by doing this, because these actually I can find easily. This is the same as this, so let me do the partial fractions. Let me make a little more space for myself. In case you're dying to know what stupid mistake I had made last time, for whatever reason I had an s squared plus 1 there and I couldn't catch it. So let's just go ahead and do this partial fractions now. 1 over s squared plus 1, s squared plus 4 equals as plus b over s squared plus 1 plus cs plus d s squared plus 4. Okay, so let's go ahead and combine them together. So 1 equals as plus b times s squared plus 4 plus cs plus d times s squared plus 1. Okay, so let's start with our s cubes. S cubes, that's going to give me 0 on the left-hand side equals, what has s cubed? There's an a and c, so a plus c. Okay, let's go to s squared. S squared, what has s squared? Well, there's the b and the d. Okay, how about s? Let's do the s terms. The s terms are going to be 4a plus d equaling 0. Sorry, 4a plus c. Okay, and finally the constant terms are going to be, so the constant terms are going to be 4b, there it's plus d, and that equals 1. Okay, so these two together give you that a and c are equal to 0. Pretty quick to see, right? A plus c has to equal 0. Okay, a equals negative c and 4a equals negative c. Okay, so a and c equals 0. Okay, these two together gives you b equals negative d. Okay, so if b equals negative d, or let's say d equals negative b, so that means b is going to equal 1/3 and d is negative 1/3. Okay, let me make this a little smaller again. Let me move this over here. And this, I'm going to make smaller because I don't care about it. Or let's put it over here. Okay, but this is really the one we need. Okay, so now our y of s equals. So b is 1/3, so we get 1/3, 1 over s squared plus 1 minus 1/3, 1 over s squared plus 4 minus e to the negative 2 pi s, and it's the same thing. Move this up a little bit to get it out of the way. There it goes. Okay, so that's going to be the same thing as this. Okay, and then we still get these pieces on the end. Okay, make it match up. Okay, now, these are all sines and cosines. Remember, the Laplace transform of cosine of bt is s over s squared plus b squared. The Laplace transform of sine of bt is b over s squared plus b squared. Let me just double check that. Yep, right here, 24 and 25. Okay, so what do we get? We're getting 1/3. That's going to be sine of t minus. Now this is missing the b, which is 2. So it's going to be if I do that, I'm going to have to multiply by 2 and divide by 2. So that's going to be minus 1/6. Okay, sine of 2t. Okay, minus u of t minus 2 pi. Okay, that's this piece times. Now I could do this, but remember sine is 2 pi periodic and so is cosine, so I don't need to worry about the shift inside of here. Okay, so I'm just going to have, this is 1/3 sine of t minus, same trick here, 1/6 sine of 2t. Okay, so that's this term going here, this term going here. Let's not forget these n terms. Let's actually try to put them on the same line. Just a little. Okay, let's move this a little bit too. Okay, so now, just to sort of recap, we're running these through. So this is going with this one. This one goes here. That's the shift thing piece. This one goes there. And then we still have these last two. This one's plus. That's going to be cosine 2t. Plus, now this one's going to be 3/2 sine 2t. Okay. All right, that's it for this. I'll see you all in the next set of videos.